Lesson 828, Shadows. Side length quotients in similar triangles. In this lesson, you'll decide if two triangles are similar by looking at quotients of lengths of corresponding sides. And we'll also figure out missing side lengths in pairs of similar triangles using the quotients of their side lengths. Oh boy, are you in for a treat today. This is Mrs. Tuitt's best art attempt. It's not my best, but it's really close. And before we jump into the notes today, I wanted to recap what we did in the lesson and talk about the ratios of similar triangles here. So this is a classic example of similar triangles where we have the sun casting some shadows with two things that are different heights. Now, I know I said triangles, and you might have to put on your special triangle goggles to see this, but I really have a triangle that I can form with the height of this tree, the length of its shadow, and the angle that the sun is casting that shadow. I'm going to go ahead and fill in this third side, which really isn't there, but you can imagine the going from the top of this tree to the end of this shadow. And there's one triangle. And that triangle comes down at a 90-degree angle. It's a right triangle. All right. And I also have this little guy here, and the sun's casting a shadow at the same angle. So I'm just going to complete this little triangle from the top of this figure to the end of that shadow. Let's pretend that's the end of that shadow. And what I really have here are two similar triangles. Remember, I only need two angles to prove that they're similar. I've got a right angle, and the sun's being cast, or is casting a shadow at the same angle from up here. And if I know two angles are congruent, this third corresponding angle is congruent as well. So these two triangles are similar. And we haven't had to worry about the side lengths with triangles because they're super special. But if they're similar, their sides are proportional. There is some scale factor that's going to connect these. So let's say I've got some information about all of these measurements, the length of that shadow and the height of this person and the length of this shadow, and I want to try to find the height of this tree. The reason that I'm starting with this is I want to do a quick review of how to solve a proportion. So let's say that I know the lengths of these two corresponding sides. So in this triangle, I know the length of this shadow is 24, and this shadow's length is 10. And those are corresponding sides in my triangles. And this tree is too tall to measure, but I know this really tall person is 7.5 feet tall. That's one side of my triangle. Well, I can find this corresponding side using a proportion. So let me see if we can set this up and solve it. And this is just a quick little review of proportions. What we're going to find in our notes is that the ratio of these two sides, so if I write the smaller side, or this left side, and then this bottom side, the ratio of those two sides is going to be the same as the ratio of these corresponding sides. Okay, so 7.5 corresponds to this tree height. I don't know what that is. I'm going to call it H for height. And 10 corresponds to this 24. Okay, so that's what I was really trying to get at, this calculation right here. You did this last year, solving proportions, and you used something called cross products. And to solve this using cross products, I'm going to go across that equal sign and multiply these two numbers together. That's what the cross means. That's what the product means. 7.5 times 24 is 180. That's going to be equal to the product of these two numbers. Well, I don't know what H is, but I'm multiplying it by 10. 10 times H. So that's the secret with cross products. And now I know 10 times something is equal to 180. And I can find out what that something is if I just divide both sides of this equation by 10? Well, 180 divided by 10 is just 18. And 10 divided by 10 is just 1. And that just leaves me with 1h. And I can write that as just h. So I set up a proportion, and now I know the height of this tree. And I could check that if I wanted to. I could see if the scale factor connecting these two similar triangles was the same. But I wanted to give you a quick review of cross products. Let's go on back to the notes. All right, our notes today are on page 91, and we really have two goals. And the first is to decide if two triangles are similar. Write kind of small. I'm going to just draw a triangle. Decide if two triangles are similar by looking at quotients of lengths. I'm going to say quotients. And another word for that is ratios. They look like fractions. Quotients of lengths in corresponding sides. I know all this is a mouthful. That's the first thing. And the second is to find missing side lengths in similar triangles. In similar triangles, I'm just going to draw a triangle again. Using the quotient of their side lengths or using proportions. And that's what we just did with our amazing, I think we should see the tree art again. There it is. We found that missing side by using these quotients and setting them equal to each other. All right, so let's go ahead and get into it. The ratio of two sides in one polygon is the same as the ratio of the corresponding sides in a similar polygon. And we can use this fact to calculate missing lengths in similar polygons. So let's say that we know that triangle A prime, B prime, C prime, and triangle ABC are similar. If we want to find the length of this side, we can use the fact that the ratios of corresponding sides have to be the same. So this side, the ratio of this side to this side is going to be the same as the ratio of this side to this side. We just have to set up our proportion carefully. Right? So let's start with our two pink sides. Well, I don't know this length, so since I don't know it, I'm just going to use X as a little placeholder. Since I can't put a number there, I'm just going to put a variable there to hold its place. So the ratio of this side to X, so there's one ratio, is going to be equal to the ratio of the corresponding sides. Well, let's think. What side does 1.2 correspond to? This one. Start my ratio over here with 3. And X corresponds to 6. Okay, well, now that we've set up that proportion, we can solve it using cross products. Remember, I'm going to multiply across. Get my blue pen here. So 1.2 times 6 is going to be equal to X times 3. I'm going to write 3x because mathematicians would laugh and laugh if I wrote x3. We put the number in front of the variable. All right. So 1.2 times 6 is 7.2. And if I want to find out the number that I have to multiply 3 by to get 7 by 7.2, Let's just divide both sides by 3. 7.2 divided by 3 gives me 2.4, or 2 4/10. And that's my missing side length. And that seems like it would make sense. If I multiply 3 by 2, I should get 6. If I multiply this side by 2, I get 2.4. All right. And let's take a look over here. To know the ratio of two sides of a triangle without measurements, using the measurements of a similar triangle, we can use that same thinking to figure out what the ratio of these two sides are. Because I know the ratio of these two sides has to be equal to the ratio of these two sides. Okay. So the two triangles are similar. We're going to find the value of k over h, or k divided by h. All right, well, let's do the same thing. I'm going to find the ratio of these two sides. Remember, we're told that these two triangles are similar. I'm going to find the ratio of those two sides. You can go ahead and just write it down now. I'm going to do 6 divided by 12. It really doesn't matter which number you put on top, as long as you're consistent when you go to the other triangle. I'll show you what I mean. All right, so I have these two sides. I just have to be careful. I'm going to start with the side that corresponds to 6. 6 corresponds to k, so I have to put k on top. And 12 corresponds to h. And that's what I was looking for, the ratio of k to h. The ratio of k to h is equal to 6/12. And you know what? I'm just going to reduce this to 1/2. That's what I was asked for. So just to wrap up, how can the lengths of corresponding sides with within similar triangles be helpful in finding unknown side lengths? Well, we can use two pairs of corresponding sides to write a proportion. Two pairs of corresponding sides to write a proportion. And then once we have that proportion, we can solve it using cross products. Oops. Just like we did in my amazing drawing here. Enjoy your homework tonight.